Hey programmers, welcome back to day 16 of the Advent of Code. Let's take a look at today's prompt. So the input file for today is going to represent some information about different tickets. And in part one, all we want to do is really focus on the first and third sections of this ticket. So we'll just pluck those out over here. So if you look at the top section of class row and seat, those lines really represent the different types of columns that we have. And they're basically saying what are the valid ranges of values for those columns. In other words, a class has values that range from 1 to 3 or from 5 to 7. And if you look at the second chunk, we have just our nearby tickets. Basically, every row represents someone's ticket, and every column is just the value of that corresponding column. Part one is really straightforward. All we have to do is identify the invalid tickets. So if I take a look at this first ticket, what I should do is make sure that all of these different columns or all these different values satisfy at least one of the different columns I have defined above. So in the case of this first ticket of 7, 3, and 47, all of those values actually fall into some column, so I'm going to consider them valid. However, if I look at the second row, I have 40, 4, and 50. If I look at the values over here, the 4 doesn't satisfy any of the column definitions. And so this must be an invalid ticket. And what I want to do in the context of the problem is just add that invalid number into my error total. But I continue to my next ticket. If I look at this one, it looks like the 55 is going to be invalid, right? 55 does not fall into any of my column definitions. So I add that into my current total. So now I have a total error of 59. Finally, the 12 in my last ticket is invalid, so I add that into my total, giving me a total answer of 71, which I should return for part one. This should be pretty straightforward to do. It's just going to be a lot of parsing. We have to figure out a clean way to actually define those different column rules. Let's jump right in. All right, so here I have my input file for this problem. Let's start by parsing things. We do have 3 different sections within this file. Let's just parse those out by maybe splitting on a double new line character. And then from there, if I do my wait to read lines, I can kind of take that as 3 different sections. To keep things straightforward, I'll just call them, we'll say section A, section B, and also section C, right? And it looks like in part 1, I only need to really worry about sections A and C. So let's just console.log both of those. I have section A and separately section C. So let's see how that looks so far. So I have a lot of data over here. And yeah, let's start parsing this stuff out. So why don't we work on just parsing out section A? It's a little shorter than section C. So we'll add that into the mix. And so what we'll want to do is really turn each of these lines into some sort of rule, right? So I'll create a function just for this. I think I'll say const, we'll say parse A. I think we're gonna have to parse each section separately. And this will give me a bunch of different lines, right? So we'll do this. What I want to do is actually call that a section. What I want to do is separate this section into its lines rather. So I'll say const lines equals, we'll say section.split. And I split on the new line character over here. That should give me an array of those strings. Let me just console.log what those lines look like. And I'll just call this function just to test it out. We'll do parse A, right? Cool, so let's see how this looks so far. Give that a quick run. So that looks a little closer. Now let's start to actually turn each of these into something we can actually use as a rule. So I think the move here is to actually turn each of these into some function, right? Because in the long run, I need to know, like, does some value satisfy these different lines? So I can have just functions that return Boolean data. So what I'll do is I'm going to store all of these functions as keys and values of an object, where maybe I'll make the key the actual just name of the field. So I'll say const rules. Starts as an empty object, and now I iterate through every line, right? So simply for, we'll say let line of lines, and I have to do my kind of tedious parsing out of data. So let me separate, let's say, the field name from like the number information. So if I do line.split, and I split on the colon space, that should give me 2 chunks, right? I think the left chunk is just going to be the name of the field. So I'll just call it field. And the other part is going to be the number information about the ranges, right? So I'll call it the maybe range string. So let's see what both of those variables look like so far. So I'm going to print line by line what the field is, as well as the range string. Cool, so that looks even closer. And now let's parse out more information out of that range string, right? Those numbers. So what I can say is if I do a range string dot split on an or, maybe a space around the or as well, then that should give me my two numbers. So I'll call that const. We'll say range 1 as well as range 2. So I'll grab those out. Let me just see what those look like now, like the test as I go. So I'll print out those two things. So just seeing those number strings. Nice. And now from each of those, I want to get the actual numbers, right? So maybe I can say something like const, I'll say numbers equals, and let's say I do range 1 dot split on a dash. And when I do that, I want to be sure that I actually get number data back from these, right? So I'll grab the number part and we'll call that numbers 1, and it should be symmetric for numbers 2, range 2, right? So we'll add that into the mix. And I think finally at the bottom, we should have our valid numbers, right? If I print out numbers 1 as well as numbers 2. So we'll see how those look now. Cool, so notice how I just converted those. So I have two separate arrays, which should now be a good match, right? Cool, so now you can put everything together. What I want to do is, into the rule object, I want to make the keys of this object refer to the strings or the fields, right? So that's simply this field variable I have up here. So I'll say the rule at the field is equal to an anonymous function. And this function I know in the long run has to return values, right? So I can make it take in a value. And in general, just return true or false, right? Does this value actually lie within either of these ranges, right? So it's a little chunky logic. What I can say is return some Boolean answer. So I know that, let's say, numbers 1 at 0 should be less than or equal to my value, and we'll say numbers 1 at 1 has to be, we'll say, greater than or equal to my value. So something like this. Cool. So what I'm saying right now is my value lies within the range 1, the first range. So if I look at my terminal right now, you can pretend that numbers 1 is this array. So I'm checking, does some value lie between 42 and 322, right? And from there, I also want to check or it's in the second range over here. Notice that they did say or within the original text, right? So that's a pretty big hint. So I'll just say the same clause, but this time make it about the second range, right? So I'll just flip these around. We'll make this about numbers 2. Just like this. Cool, so that's looking pretty good. Once I actually define those functions for everything, I just want to return that rules object. So we'll console.log what the rules are. It should just be an object whose keys are strings, but whose values are anonymous functions. We're getting a little bit of error here. It says rule is not defined. So let's fix that. So it should be rules with an S over here. Try that again. Nice, and that's looking pretty good. Awesome, so now that we have these nice rules, we're gonna have to actually parse out, looks like this third section, which are tickets. So let's see how that looks. So I'll save this as my rules. So section C, it's kind of annoying looking as well, but we must deal with it. Let's turn each of these just into their own arrays, right? So not too bad actually. We'll say const parse C equals some function takes in a section. I think I could start the same way, right? Still split on every line, but this time maybe return, we'll say lines.map. So convert that for every line. I want to convert into an actual array of numbers. So I'll say line.split on a comma. So I'm splitting on the comma. That should give me an array of strings, but I actually want an array of numbers. So convert those to number type, right? So that should be good. And then let me actually call that function. So we'll test it out over here. So let me call parse C on that section C. And I hope to get back a 2D array, right? So I'll call this my tickets. And specifically, it's really my nearby tickets. It doesn't include my own ticket. So remember, my own ticket is kind of a separate section B. So let's see how those nearby tickets look. Console.log nearby tickets. Cool, so I have my multi-dimensional array. And now I'm ready to put everything together. So I know I have to count the total number of error over here. So I'll say let error total, something like that. And I know I just want to really check or take the sum of the values that don't satisfy any rule. And so right now my data is very separate. I have my separate rows of these tickets, as well as my separate functions. So what I can do is maybe convert all of my rules. So right now rules is an object. Recall that rules is an object where keys are just the fields, right? And values are the functions. I really just want an array of all the functions. So I can say all rules equals, and we'll convert those. So we'll say object.values. So I'm getting the values or just the functions out of that object. Nice, just some classic JavaScript. And then from there, let me also turn each of these arrays into a single array. That way it's just easier to iterate over, right? So I imagine if I console.log all rules, I have very flat data, which I think is a good fit, right? So this is what I'm referring to, right? It's just an array of functions. And in a similar way, if I did, let's say, nearby tickets.flat, it's an array method, it'll convert these 2D arrays into just a single array. That way it's very easy to iterate over. So notice how flat this one is. I notice I am seeing a not a number, probably because the first line of section C is this kind of label of nearby tickets, which we don't want. So let me fix that right now. Maybe I'll grab just all the lines after the first one. So I should get rid of that not a number, right? Awesome. But back to this, now that I have that flat array, I can begin my main iterations, right? So I can say for every, we'll say let val within these. So I'll save this array as values. So for every value of the values array, I want to check, right? If it does not satisfy any rule, right? Or all rules rather. So I'll say all rules dot every, some classic JavaScript methods. And so for every rule, go ahead and call that rule. So it's just a function really that, you know, returns Boolean whether or not some value satisfies that rule, right? In particular, I really want to check if every rule is false for this one, right? So put this on the outside actually. Because if it's false for every rule, then it can't possibly be a valid ticket. So I'll say const is valid. Maybe here the appropriate answer would be is invalid, right? So we'll write it like this. And then quite simply, if that value is invalid, then I add it to my error total, right? Just like this. Cool, and I think at this point, we'll just return the error total. Cool, and if I look at my code down below, I have a little typo. I see this numbers 2 is dimmed out, because over here I just said number 2. It should be numbers. So that looks a little bit better, maybe a semicolon 2. So definitely a lot of room for error here. We'll kind of see what we get. So I should get the answer, at least for my input, of looks like 29,000. Let's give that a go. Nice, and there we have a quick solution for part 1. All right, let's move to part 2 where I think most of the fun happens. So in part 2, our plot thickens quite a bit. So we're still going to have our 2 main chunks of input. We're going to have our column definitions as well as some nearby tickets. But this time what we want to do is figure out which columns actually match up with which column definitions, right? So we'll kind of clean things up over here. Here I have the same ticket information, but I just have labeled the different columns. I'll call them A, B, and C. So how should we start attacking this one? If I want to find the correspondence from the actual labels of class, row, and seat to their actual column numbers, we're going to have to really deduce that by eliminating possibilities. So let me start by looking at my very first column. What I can do is identify what different labels actually could meet with this column. In other words, if I kind of iterate through things, let's say I'm looking at column A, and I'm looking at this first label over here of class. If I ask myself if all of the values in the column A are compatible with the class, it's actually not the case because of the 3, right? The value of 3 does not fit with class, so I don't add that to the possibilities of A. However, if I look at the column A again, but compare it for the row would be compatible, so I add it to the list. Now if I check for compatibility between the seat label and column A, this is not going to work out because of the value of 15, right? 15 does not fall into the seat range. So it looks like for my very first column, the only possibility is for row. And I just continue this process for my other columns, right? If I look at B, I'm going to figure out that B is compatible with the class, as well as that B is also compatible with the row. B happens to not be compatible with the seat though. Finally, if I move to my final column of C, turns out that C is compatible with all of these different labels. At this point, I've defined all of the possible labels that could match with these columns. And now here I can actually perform my main algorithm. So from these possibilities alone, I have to come up with a strategy to actually deduce what labels belong to which actual column. And just by looking at this object or this mapping I have right now, we can already see a little bit of a pattern, right? So how can I start over here? Well, if I take a look at the possibilities, something I notice is A, or the column of A, only has one possibility of row. So if that's the only possibility, then it must be the case that A is definitely going to correspond to the row. So I can make that logical move over there. And once I've actually chosen something that has the label of row, from there I can actually remove it from all of the possibilities of my other columns. And at this point, I've just made it such that another column of B now only has one possibility, right? B must be class. So I have that in my answer as well. At this point, I can remove class because it's no longer available. And finally, if I look at C, it must be the seat label. And at this point, I figured out the exact correspondence for my columns into their labels. That actually isn't too difficult of a problem to solve. Let's start coding it up. All right, so for part 2, in the instructions, they do tell us to actually discard all of the invalid tickets, so I'll do that right now. Right now, I have all of the original code from part 1, so I definitely need to refactor it a little bit. So I no longer care about counting the total of things. I do want to just get the, I'll say, valid ticket, so I can use a lot of this logic still. So I'll say maybe a helper function, const, say get valid. I'll refer to them as rows, maybe that's clearer. And I'll take in all of the rows. And I can use much of the same logic over here. So I'll go ahead and for every row, check how it matches the rules, right? So I need to definitely pass in some rules here. Cool, and I could still stay as all rules. Maybe I'll assume it's the rules object and I'll turn it into all rules over here, right? So let's start to freshen this up, something like this. So I expect get valid rows to be called with the nearby tickets, as well as that rules object, which I turn into all rules, right? Still invalidating them in a similar way. So I can say maybe return, and what I want to do is just choose some of the rows, only the ones that are valid, right? So I can say rows.filter, and for every row, check if it, is good enough, right? If it's valid. So let me give myself a full body for this filter. And what we'll choose to do is still check if any of the values are invalid here, right? So I can say row.sum. So the sum value in that row fail, right? So I can say row.sum for every value. I want to check if that fails all of my rules. So super nested code here. we'll say all rules dot every, just like before, for every rule, does it give back false when passed in, right? With the value. Cool. So let's kind of boil down what this code is saying. So the way I read this code is I want to choose the rows that don't have an invalid value, right? An invalid value is one that fails every rule, so it's not compatible with anything. Cool. So let's see this in action. What we should be able to do is notice a reduction in the number of rows, right? Definitely from part 1, we saw that some values are invalid. So I'll say const, we'll say valid tickets equals that. And I think, well, just console.log the number, right? So I'll print out the number of valid tickets. Before then, I'll print out the number of nearby tickets. It should be reduced, right? So let's give that a shot. We'll run node part 2. Cool, so we're getting a little error over here. Something I forgot to do is actually give this inner function a return value. So I'll return it like this, right? That way I get some Boolean data. Nice, so we go from 245 to 190. Awesome. So I think now we're ready to actually put everything together in our main solution. So what I want to do is really now analyze the columns, right? So what would be nice is if I can maybe like transpose things over here. In other words, if I look at all of my rows, maybe just in my input file, right now I need to identify how these columns, remember columns go vertically, how these columns should be arranged for these different labels over here, right? And so just to make it easier to like index and perform operations on, I think it's going to be helpful to actually rotate this, if you kind of thought of it as a grid, right? So we'll put that in the mix. Well, let me create a function for that. We'll say const transpose. Usually, you know, a lot of JavaScript, or rather programming languages that are not JavaScript, come with some built-in function, just rotate a grid, but we'll have to build it manually here, I think. So I'll say take in some grid, which is really going to be that 2D array of tickets, and just transpose it, right? So I can create some const new grid, and I can just iterate through the indices here, right? So some classic, we'll say let row equals 0, while the row is less than grid.length, do row plus equals 1. Then something very similar for the second one, right? So we'll add that in, put the column over here. And I know that my original value is going to be at grid of row column. If I want to just transpose it, so kind of flip the rows and columns, then I can say new grid of CR equals that. So this just rotates the grid, right? So we'll return that. And let's just test this function really quick. So if I were to call transpose, let's say I passed it in some grid, right? It doesn't even have to be a grid of numbers. So we can just say A and B, and also C, D. So let's say we also add another row. We did EF over here. What I want to get back is the rotated version of this. So I'll say transpose, just a quick little test, right? So console.log transposed. Let's give that a shot. So I'm getting an error here, cannot set property 0 of undefined. Of course, on line 18, I definitely want to make sure that this is going to be 2-dimensional, right? So it should have the right dimension. So do a few things here. So I want to size this properly. I'll say create an array whose dimension is the number of columns, right? So notice how I'm flipping things around here. Then I fill it up with some stuff. What I'll do is map over it and make the inner elements an array. Right, so this should be good to go. So still getting an error over here. Let's make sure we did this right. Starting at 0. Over here, I should be having my grid at index 0 though. All right, because I have a different number of rows and columns in this instance. Cool, so that looks much better. Let's take a look at that again. So notice how we kind of rotated things, right? The first row is now technically the first column, right? Same thing for the second row, second column. So just rotating things about. And that should be perfect for actually now solving this main problem. A lot of moving pieces to this day 16, part 2 for sure. Cool. So what we want to do now is figure out the options for every different column, right? And now I have the columns separated. So I'll say transpose of my near, or rather valid tickets. And now I'll call those my columns, right? What I want to do is figure out, which columns match with which rules. And so what I'll decide to do over here is maybe create maybe an array where the indices of that array represent the column numbers. So in my kind of example, I used A, B, and C, but now there'll just be some numbers. And then I have it point to like a collection, all of the rules that satisfy with it, right? So I'll say const possible, very similar to our drawing. And I want to fill up this array. So what I'll do is I'll iterate through every column. So I'll say for column, and we'll start at 0, go up to the length of columns, hit every column. Nice. And then from here, I'll decide to grab the actual column. So I'll say const column equals that particular column. So call num. Maybe for clarity, I'll just call this num. Looks a little less like the other variable names. Nice. And now I want to fill things up over here, right? So for this column, I want to figure out all of the rules that it could match with, right? So what I can say is for let, we'll say rule of rules. We'll say field in rules rather, because it's an object, right? So field in rules. What I want to do is check if it's compatible with this column, right? So that's pretty straightforward. So I'll say const the rule we'll get out of that object is a function as always, right? So I'm just keying into that object just to make sure we're on the same page. We'll console.log the rules. So remember that it's a object, right? So field would be something like departure location. And then when I key into it, the rule would be this function. And to check if this column is compatible, all I need to do is make sure that every value in the column satisfies the rule. So I can use an every here once again. So I can say, let's say column dot every. And so does every value in that column satisfy the rule? So I'll pass that in. I know that the rule function always gives back a Boolean, so this should be good to go. I'll save this into a variable. We'll call it is compatible. Nice. And so if this column is compatible, then I want to add it into my possibilities for it, right? So I'll say possible. Actually, I need some collection here. So maybe I'll have a nice set. So I'll say const set equals a new set. And I want the set to just refer to the field that apparently is compatible, right? So if it's compatible, then simply say set.add. Just go ahead and add the label, right? So that should just be add field. That's compatible. So that looks good. And once I fill up that set with all of the field names that are compatible, then I ought to actually say possible options for the column, which would just now be my number, set that equal to be the actual set. Cool. So do notice that we're using indices to represent the actual column numbers of this array. So some heavy logic. This was a tough problem. Let's go ahead and console.log what possible looks like. So it should be a bunch of different sets at these indices, right? So not quite, we're getting an error here. So I is not defined. So why is it complaining about an I on, looks like line 17? Oh, yep, change this, should be num. Give that a run again. Cool, and this looks better, right? So here we have our different options. Here's what we'll do. Why don't we actually bring in that very small test file that we kind of trace through on the whiteboard, right? So that should work fine. So here's the input file that we traced through on the whiteboard. Let's just see how things look if I run my code on that input file. So we know we're going to have way smaller number of things. Nice, and this does look familiar to what we explored on the whiteboard. So I think we're ready to put things together. So after this, I'll remove all this code. So I've created all the possibilities. Now I want to actually narrow them down, right? So finally putting everything together. We want to locate the columns that only have one possibility because they must match up, right? So there are a few ways we can kind of structure this. We definitely need some sort of a loop and some object to have that correspondence mapping. So I'll say maybe const create the map between the column numbers and what their actual labels are. And what I'll do is just keep iterating basically while this map doesn't have everything it needs, right? So maybe we'll just iterate while the keys of this object aren't big enough, right? So I'll say object.keys of map. Well, that is less than the number of rules, right? So number of rules would be like this stuff. Cool. It'll also be the same thing as the number of columns. So maybe we'll just go with that. We'll say columns.length. Cool. And here I begin the algorithm that we trace through, right? So at this point, I want to find the columns that only have one possibility. So pretty straightforward stuff. I'm going to iterate through possible. So I'll say for let, we'll say call in or call equals 0, call less than possible dot length, and then call plus equals 1. So I'm iterating through possibilities. Remember that this array, the indices correspond to actual column numbers, right? So what I want to do is access those different sets. So I'll say const set equals possible of this column. And now I want to check the size of this set, right? So I'll go ahead and check, hey, if this set.size, if it's equal to 1, then I can make a logical deduction right now. So if it's equal to 1, then I want to actually just get that element, right? So I can say set, and what I'll do is over here, kind of have to get the lone element out of the set. So I would just turn it into an array, then index it, index 0, because I know that it definitely only has one element. So this will grab me that element. And I'll call that my actual, we'll say label. So label would be something like class row and seat, right? Nice, and at this point, all I need to do is in my map, I know that that label now belongs with that column that I just, took that label from. So that's looking good. So I found some mapping, and I have that in my answer set. What I want to do now is also remove that label from all the other possibilities, right? So I think I would have to nest code over here. So we'll say for all the other sets. So we'll use some syntax here. So we'll grab every element. So we'll say for let, we'll say other set of the possible object. Want to actually just remove that label, right? So I could just say other set dot delete the label. So we would just keep running this code for every single column. So I think at this point, this code actually might be good to go. Let's just console.log what the map should be. So I hope to not get an infinite loop and have a full map object. We already kind of saw the answer for this very small input before on the whiteboard. So let's see what that gives us. Cool, so there we have our correspondence, and it actually looks correct. So yeah, I think we're ready to actually just run this on our main input. So we'll add that into the mix. Crazy code, I know. Nice, so that looks a little bit off, unless my input is just that small, right? Because this object, I imagine, should be much larger for my particular input, right? So let's see what we did wrong over here. Just a little typo on my end. I definitely want to check that the number of keys, right, is less than columns.length. So basically, while I haven't found every single label correspondence with a column number, so let's try that now. Cool, we get some big object. That looks much more reasonable. And to actually put everything together, what they have us do in part 2 is really just get all of the values in my ticket that start with like departure, and then just multiply them all together. So one final step, I'm not sure why they kind of make us do this. It's pretty tedious, really. I want to actually look at my ticket. So I have to actually parse that part out. I didn't do anything for section B, right, which is my ticket. So we'll just go ahead and create that function. We'll say const, I'll say parse B. It's going to take in that section. And I already know that that section begins with some weird header, which I just want to ignore, right? So I can say section.split on the new line character. And I want to just grab the second element of that new line, right? Or after those new lines. And I'll call that my const. We'll say ticket string. So I would get really just this as a string. I just want to convert those into numbers of an array, right? So like we always do, you can say return ticket string dot split on a comma, and then we'll also map over each of those to get number data. Something like this. So let's see if I can parse out my ticket correctly. So that means down here, maybe I'll say const my ticket equals parse B. And we'll go ahead and pass in section B, right? So let's see what my ticket is. So I should be getting something that starts with 67107, right? So 67107, nice. There's my ticket. Cool. And now what I want to do is basically multiply together all of my values for the fields that start with departure. So let's put all of this together. So what I want to do is calculate some product. I'll say let product start equal to 1 and iterate really over all of the fields that start with departure only. So we'll say we'll say let label, we'll say field in the map object. So map contains like my answer, basically this object. So for field in the map, I'll say if that field starts with the text departure. So it should be like this, departure. If it starts with that, then I should actually grab the column index, right? So I can say, we'll just say call num equals whatever is actually in the map associated with that key, right? So let's say my field is departure time, right? I'd be keying into it and getting the column number of 2. So just key into it using field. That gives me my column number. And now finally, to put everything together, I can just take that column from my ticket, so my ticket at column number, and multiply that into my product. So times equals over here. And my final answer, I believe, is just the product. So let's see how this works. I should get some very large number. It starts with 5178. So let's give this a shot. 5178, nice. And there we have part 2. Pretty crazy problem. Once we get all the setup done though, the main algorithm, in my opinion, would be kind of this bit, right? Kind of removing possibilities until we know for a fact that some label must correspond with some column. Cool, so that's all I got for day 16. I'll catch you tomorrow for day 17.